All right, now we're getting some new stuff. So we got measures of spread. All right, and we're going to look at just one measure of spread today called standard deviation. And what we use measures of spread for is to tell us how the data is spread out, whether the data is really close together, whether it's spread out. And this is usually used to see how strong your statistics are. So this is used a ton in like medical research or market research or all those kinds of things. So this is something that's used quite often in the real world. So we're going to get both these lists typed into our calculator. So if you go into your statistics and edit, and if you notice, I have both my lists typed in. Just make sure you have 10 pieces of data for each. So pause your video and get your list typed into your calculator so you can follow along with the rest of it. So the meaning of standard deviation, it describes how close or how spread out the data is from the mean specifically. Okay, so the mean, is the average. So we're looking at like how close or how far away the data really is, kind of almost on average. And we have this super fancy notation for standard deviation. So kind of confusing. Let's kind of break it down. If you notice, this is from Plier. So this is like representing each piece of data. So what you're really doing is you're taking each piece of data and you're subtracting the mean, and then you square that value, and then you do it all over again, right? Because remember, this means the summation. So you'll basically do that for the first one, minus the mean. You'll square it, and then you'll add it to the second one. You'll do it to the second one. And then you'll square that, and you'll just keep going until you do it to all of them. And in the end, you divide by n minus 1. So if there's like 10 pieces of data, you go 10 minus 1 to give you 9. And we'll take a look at this piece by piece to make some sense. So we're going to do one by hand and then by calculator, because it's good to do it by hand to kind of understand what this really means. So that's the one we're going to work with. So by hand right away. So the first thing, you have to find the mean. Well, I already found it for us. We added them all up. Add up your 45, 47, 46 all the way, divide by 10, and we should get 45 for the mean. So get used to writing X bar to represent your mean. Then it says find the deviation from the mean for each value in the data set. So that's what we're using to represent. So we take our piece of data, the X of I, minus the mean. And we do that for each one. So I'm going to put that in my table right over here. So 45 minus 45 is 0. It doesn't deviate from the mean at all. That's what that word deviation means. That's like how far is it away from it. So here we have a positive to it, deviates 2. And the reason it's positive is because 47 is really like 2 above the mean. That's why it's a positive 2. So 46 minus 45 is 1, and then we got 2. Now we get a negative 2, right? Because 43 is below the mean by 2. So that's why it should be negative. And then we got 1 and 0 and negative 3 and negative 2, right? So we just subtracted, right? 45 minus 45, 47 minus 45. Just subtracted the mean from all those. Okay, so that was our first step. And then if you remember back to what we just looked at before in the previous slide, we square all those numbers. So that's the next thing. We're going to square the deviation for the mean for each data value. And so now I'm taking this table and I'm squaring all of those. So 0 squared is 0, 2 squared is 4, 1 squared is, whoop, I almost wrote 2. 1 squared is 1, right? 2 squared is 4. Just imagine you have parentheses around it. It's like negative 2 squared, right? Negative 2 times negative 2, so that's also 4, 1, 1, 0, 9, and 4. So there we go. So we squared all those. And then we had that fancy summation, right? That E written in front of this with the I starts at 1, and we're going to the nth term. So now we're going to add all those up. So we're going to add all those squared values together. So I got 0 plus 4 plus 1 plus 4 plus 4. Just adding them up on the side as I go. 15, 15, 24, 28. And so our sum is 28. All right, and what do we do with that again? After we add all those up, we divide by n minus 1. And what we call this is the variance. Okay, so now we added them all up. That's what that summation was. So that was 28. And we divide by, well, how many pieces of data were there? 10. So 10 minus 1 is 9. And our last step, which I actually forgot to put on my original definition of standard deviation, is to take the square root. So sorry about that. So if you go back, make sure you get that on there. So there should have been a square root bar on your original definition. And so standard deviation, so here we go, equals the square root of 28 over 9. So that's really the square root of 28 over the square root of 9, which is 3, which is approximately 1.76 right in there. Okay, so that took a little bit of time. So we want to be able to do this with our calculator. So if you remember, our statistical list had list 1 with all that data. So we're going to go back into statistics and remember our calculations and one variable statistics and list 1, just like we just looked at, and calculate. So now this is the thing that we didn't look at yesterday. Well, where is that standard deviation? Right here. S with the x equals 1.7. There it is right there. So it just calculates it for you. So that's represented by the S. And then they'll usually put the x, because this is standard deviation of that data set, was about 1.76. So there we go. So the rest of that data, this is kind of used to calculate that standard deviation. And we're not going to worry about this. If you take AP stats later, this is something that you'll be concerned with. But here's our standard deviation. So what does that really mean, that 1.76? Well, what that's saying is our standard deviation is about 1.76 for this green stuff over here. It's saying our data deviates from the mean, a little less than 2 at a time. So it says my data is pretty close. So the smaller the number, the closer my data is, right? So my mean was 45, so that means most of the data is pretty close to the mean. And statisticians, what they'll do is they'll sometimes look to see how many data values fall within 1 or 2 standard deviations of the mean. So if we look at it, if 45 was the mean, this falls within 1 because it's exactly the mean. That's the same thing as the mean. This is 1 away, so that's within this first standard deviation. All these values are within, they're either plus or minus 1.76 away from the mean. And so we're going to look at that other set of data to see if there's any outliers in there. And for outliers, that means values that are significantly different than the majority of the data. And what we're going to use, different statisticians will use different things, but we're going to use any value that's more than 1.5 times the IQR away from either quartile. So if it's 1.5 times away smaller than the quartile 1 or greater than quartile 3. So let's take a look. There's my data, which I should have had typed in the calculator. So let's just, instead of doing it all by hand, let's go and we want statistics and we want calculations. One variable statistics. Now we're dealing with list 2. So I'm going to select that right here, L2 in the blue, off that number 2. Okay. And let's calculate. All right, let's go down to our 5-number summary because I need the interquartile range, don't I? Okay. So my quartile 1 is 23 and my quartile 3 is 68. So quartile 1 is 23 and my quartile 3 is 68. So what is the interquartile range? Remember, you subtract the 2, which is 45. So I'm looking for data that is 1.5 times the IQR away from either. Okay, so I have to take 1.5 times 45. So 67.5. Well, is there any data that's 67.5 away? So that's basically saying if I take quartile 1, it would have to be 23 minus 67.5. Well, there's nothing in the negatives. That's good. And quartile 3, you would take 68 plus 67.5. So is there anything outside of that? Nope. So there are actually no outliers. It looks like there should be some outliers, but since our data is so spread out, there is no outliers. Okay, so that's where it gets kind of confusing. Some people might think that like 6 is an outlier, but since the data is so spread, it's actually not when we're considering the interquartile range.